Have you ever wondered how your favorite websites or mobile apps work so smoothly? Ordering a pizza online, booking a movie ticket, checking your bank account. Behind the scenes, a lot of complex work is happening. Programmers need a reliable way to build these powerful applications. This is where something truly cool called the Spring Framework comes into play. It's like a giant, super helpful toolkit for developers. Instead of starting from scratch every single time, they can use Spring's pre-built parts to create amazing things, faster and more reliably. It provides a solid foundation, a blueprint if you will, for building robust and scalable applications. So what exactly is a Spring application? In the simplest terms, it is any software application built using the Spring Framework. Imagine you're building a house. You could chop down your own trees, make your own bricks, and forge your own nails. Or you could go to a hardware store that has everything you need, all ready to go. The Spring Framework is that hardware store for software developers. It offers a comprehensive programming and configuration model for modern Java-based applications. This means it helps organize all the different pieces of a program so they can work together harmoniously, making the developer's job much easier. At the very heart of the Spring Framework are two brilliant ideas that sound complicated but are actually quite simple. Inversion of control dependency injection. Let's break them down. Imagine you're cooking a fancy meal. Go to the store, find all the ingredients yourself, bring them home, start cooking. Now, what if you used a meal kit delivery service? The service does the hard work for you. It gathers all the pre-measured ingredients, the dependencies, and delivers them to your door. All you have to do is assemble and cook them. This is inversion of control. In software, inversion of control works in a similar way. Instead of your code creating and managing all the objects it needs to function, you hand that responsibility over to the Spring Framework. The framework, often called the IOC container, acts like that meal kit service. It creates the objects, manages their entire life cycle, and provides them to your application whenever they are needed. This inverts the typical flow of control, taking a huge burden off the developer. Your code doesn't have to worry about the nitty-gritty details of object creation. It can simply declare what it needs and trust Spring to provide it. It's a fundamental shift in thinking that leads to cleaner, more organized code. This brings us to dependency injection. This is the how of inversion of control. Dependency injection is the process through which the Spring container injects the necessary objects, the dependencies, into your code. Let's visualize building an application as constructing a large, complex Lego model. Every Lego brick is a piece of code, an object that does a specific job. If you just have a giant bin of unsorted bricks, building your model is going to be chaotic and difficult. The Spring Framework acts like a set of organized trays and instruction manuals for your Legos. It provides different modules, which are like pre-sorted kits for specific tasks. Need to build the part of your app that talks to a database? Grab the Spring Data module. Need to secure your application so only authorized users can log in? Use the Spring Security module. Each of these modules is designed to handle a common problem in web application development. For instance, the Spring MVC module is a complete kit for building the user-facing part of a website. Model View Controller. This separation makes the application much easier to manage. If you need to change how a web page looks, you only have to work on the view without touching the underlying data or logic. It's like being able to swap the color of your Lego car without having to rebuild the entire chassis. Let's walk through a simple scenario. Imagine you are building a simple blog application. First, you'd use Spring MVC to handle web requests. When a user types your blog's address into their browser, a controller would receive that request. The controller would then ask another part of your application, maybe a post service, for the latest blog posts. This is where Spring's dependency injection shines. The controller doesn't create the post service itself, Spring injects it automatically. The post service then uses the Spring Data module to fetch the posts from a database. Once it has the data, it passes it back to the controller. Finally, the controller bundles this data, the list of blog posts, and sends it to a Vue template. As powerful as the Spring Framework is, setting up a new project from scratch used to involve a lot of configuration. You had to manually set up all the different modules, write lots of configuration files, and make sure everything was connected correctly. It was like having to assemble all your Lego trays and read several instruction manuals before you could even place the first brick. To solve this, the brilliant minds behind Spring created an even smarter tool, Spring Boot. Think of Spring Boot as a highly skilled assistant who knows exactly how you like to work. It makes building Spring applications incredibly fast and easy. Spring Boot takes an opinionated view of the Spring platform. It comes with sensible, pre-configured defaults based on best practices. When you start a new project with Spring Boot, it automatically includes and configures the most common libraries you'll need. For example, if you say you want to build a web application, Spring Boot automatically includes a web server like Tomcat and configures the Spring MVC module for you. You don't have to do any of that setup yourself. This convention over configuration approach lets you go from an idea to a running application in just a few minutes. One of the most magical features of Spring Boot is its auto-configuration. It intelligently looks at the libraries you've included in your project and automatically configures the necessary Spring beans and settings for you. For example, if it sees that you've included a library for connecting to a specific type of database, it will automatically set up the connection for you, assuming you follow some basic naming conventions. This eliminates tons of boilerplate code and configuration that developers used to have to write by hand for every single project. The principles and tools we've talked about aren't just theoretical. They are the backbone of countless real-world applications you probably use every day. Major companies across the globe rely on Spring and Spring Boot to build and run their most critical systems. Why? Because it's scalable, reliable, and secure. When you're dealing with millions of users and transactions, you need a framework that has been battle-tested and proven to perform under pressure. Spring provides exactly that. It's the industrial strength stuff. Think about the world of e-commerce. When you browse a site like Amazon or place an order on a platform like Ticketmaster, you are likely interacting with a system built on Spring. These platforms need to manage massive product catalogs, handle secure payments, process orders, track inventory, and serve personalized recommendations to millions. Spring's modular design is perfect for this. Different teams can work on different microservices: payment service, user account service, inventory service, and Spring helps them communicate as one cohesive system. It's not just for giant online stores. The financial industry relies on Spring for banking platforms, trading systems, and fraud detection engines. These apps demand top security and reliability. A single error could have massive consequences. The robust, well-tested Spring ecosystem, especially modules like Spring Security, gives financial institutions the confidence they need. Many top streaming services you use for movies and music, like Netflix, use Spring Boot to power back-end services that deliver content to your screen. In conclusion, Spring plus Spring Boot is a dominant force in software. It simplifies complexity with inversion of control, dependency injection, a modular Lego-like approach, and intelligent auto-configuration that speeds development. From booking your vacation to streaming your favorite show, Spring apps work silently in the background, making our digital world possible.